So fellows, here we are yet again with another video. This time I am trying to interface the Raspberry Pi with an EEPROM chip that I have here. This is the EEPROM chip that I have. This 25LC640 EEPROM chip. It's a SPI EEPROM. Hence, an SPI interface requires to be created to write or read in the data into this EEPROM. So hence this circuit has been made around to write the data using this Raspberry Pi. So basically the clock signals have been tapped into using this expansion slot, as you can see here. The MISO clock signals, the MIMO, the master slave signals, and the basic handshaking signals that we have used here. And apart from it, these two pull-up resistors have been used here, and these resistors are very important, and they are used basically for pull-up, and without these the voltage levels won't be proper, and we won't be able to write data into it because it requires somewhere around 3.3 volts of power supply. So hence using this EEPROM, using this Raspberry Pi, I am trying to write into data into it. A small program has been written, which I am going to show it now. Here, if you see here, this Raspberry Pi EEPROM test.c, this is the file that I have here. So if I open it, so here you can see this program that I have used here. So to begin with, I am trying to flash a binary, basically a binary into this EEPROM. So this EEPROM will store a binary. So basically what I am trying to do is that I am trying to open this SPI device connection, and then I am trying to use this wrapper. This wrapper is wiring pi. This wrapper's functions are provided by wiring pi named module that I have received from internet. Apart from it, basically in the program, the main thing to be noted is that this EEPROM is having a page size of 32 bytes. Hence, we are trying to write into the write mode, and after that we are trying to send the data. That is, we are trying to write the data, and only at one time we can write 32 bytes of data only after reading the file. So here you can see I am trying to read the file fread, and after that I am trying to write the data into it. So only at one time only 32 bytes of data are being written here, and after that in the next time again the address has to be incremented to jump to the next page, and next page again 32 bytes of data are written, and in this way the operation goes on, because it's divided into pages. The EEPROM memory is divided into pages, and we need to keep track of the page size, and in that way we can, if we keep track of the page size by using some variable and using some count variable, and try to only write at one time 32 bytes, then the write is successful. If it is more than 32 bytes, the write won't be successful, and the number of bytes that would be written won't be written, but the bytes won't be written into the EEPROM. And in this way I am trying to write around 4.9 KB of data of my binary into this EEPROM. And let me show you how to run this program. This program has been compiled using the GCC of this board. Actually, the board provides The Raspberry Pi provides an inbuilt ARM compiler. Using that ARM compiler, I have compiled the binary for ARM platform. And if I run this program, you'll see here I'm getting at each time how many bytes written, and at last the program exits, and we are writing 32 bytes of data at each time, as I have told you. So this was all about it. This was all about this small project that I tried to do using this Raspberry Pi. Instead of buying an expensive EEPROM programmer, I have written data into the EEPROM using just the help of Raspberry Pi, and I am very much helpful to the articles that are there in the internet. So thank you very much. Thanks for watching.